Hi friends, so in this video we will be discussing about minimum spanning tree and Kruskal's algorithm for finding minimum spanning tree. So what is a spanning tree? A spanning tree in a given connected and undirected graph, it is a subgraph that is a tree and connects all the vertices together. That is, whenever a connected and undirected graph is given, we will be constructing a subgraph which is a tree which contains all the vertices in the graph together. And a given graph can contain many different spanning trees. Generally, the maximum number of spanning trees in a given undirected graph is n to the power of n minus 2. So that is what a spanning tree is. So whenever a connected undirected graph is given, we will be getting a maximum of n to the power of n minus 2 spanning trees. So now the concept of minimum spanning tree or minimum weight spanning tree is that in this n to the power of n minus 2 spanning trees, we have to find a spanning tree with weight less than or equal to all other spanning trees. So this is what the concept of minimum spanning tree, that is, out of all the spanning trees of a undirected graph, we have to find a spanning tree with minimum weight. So that is what called as minimum spanning tree. So whenever we are talking about a minimum spanning tree will be having v minus 1 edges, where v is the number of vertices. If a graph has v vertices, then the constructed minimum spanning tree will be having v minus 1 edges. So for example, here we have given a complete undirected graph. Here you can say there are 6 vertices. Then the spanning tree which we construct will be having 5 edges. Okay, so to construct a minimum spanning tree, the most two important algorithms are Kruskal's algorithm and Prim's algorithm. So let us discuss about Kruskal's algorithm for finding minimum spanning tree. So whenever we are talking about Kruskal's algorithm is based on greedy approach. So Kruskal's algorithm will be using the concept of greedy approach. So let us understand Kruskal's algorithm with an example. So we are considering a complete undirected graph which will be having 6 vertices, okay, and every edge is associated with a weight. So using this graph, using Kruskal's algorithm, we will be finding minimum spanning tree. So let us go on. So the first step in Kruskal's algorithm is remove all the loops and parallel edges. That is, in a given graph, if there are parallel edges, we have to remove it. If there are loops, we have to remove it. So what are parallel edges? Parallel edges are the edges which with 2 vertices will be having 2 edges or more than 1 edge, then they are called as parallel edges. So whenever there are parallel edges, so in this example we have A to B, we have 2 edges, one with a weight of 9 and one with weight of 6. So we have to remove parallel edges, and remember that whenever we are removing the parallel edges, we have to remove the edges with greater cost, and minimum cost edge should be kept. So here minimum cost edge is 6, so we will be keeping 6 and we will be removing 9 parallel edge. And coming to the loops, so what is a loop? A loop is an edge to the same vertices. Here is the example of a loop. So here C vertex has a edge with one weight which is to itself, so that is called as loop. So we also remove loops. So that is what the first step is. So coming to the second step, after removing the parallel edges and loops from the graph, now we have to consider the weights of all the other edges, remaining edges in our given graph, and we have to make a arrangement in increasing order of the weights. So now you can see there is an increasing order of the weights, that is BD with 2, DT with 2, AC with 3, CD with 3, and so on. So we have arranged it in a monotonically increasing order of the weights among the edges. So after arranging that, we will be moving on to the step 3. So from here in step 3, what we will be doing is we will be considering the minimum weights and we will be constructing a tree adding all those edges. So first, when you see minimum edges are BD and DT with two weights. So BD and DT are added to our tree. So next minimum weight cost is 3, and it is associated with the edges AC and CD. So we will be adding AC and CD. You can see AC and CD. So next minimum cost is 4, and you can see whenever we are adding 4 between CB, now there is a chance of forming a circuit, that is there is a circuit formation. So whenever there is a formation of a circuit, then we will be not adding that edge, we will be ignoring that, that is edge CD will be ignored, and we will be getting this graph which contains a tree. Okay, so now next cost is 6, 5 and 6 which are also forming a circuit, that is adding AB with 6 and adding BT with 6, that is if we add this edge, there is circuit formation, if we add this edge, there is a circuit formation. So forming of circuits will not be allowed. Okay, circuit is formed, so forming of circuits will not be allowed, so we will be ignoring the weights of 5 and 6 edges, and that edges will be ignored, and we will be getting this graph. So remaining are the edges with 7 and 8, cost 7 and 8, and the minimum cost is 7. So the edge between S and A will be added, and now you can see all the vertices have been covered. 6 vertices have been covered, and we have constructed a minimum spanning tree, and you can see we have 6 vertices and V minus 1 5 edges. So this is what our minimum cost spanning tree is. Hope you understood. Thank you.